Good afternoon. My name is Edward Kent. I'm a principal developer in the data engineering squad at AutoTrader. I've been working at AutoTrader now for just over 7 years. In my time, I started off working specifically in the valuations squad, working with data to produce real-time valuations of used cars. And over time, the squad I worked in has evolved, as has the work I've been doing, to become a more overarching data platform, which is what I'll be talking to you about today. So the title of the talk is Democratising Data, how we built a self-serve data platform. So the agenda, I'll give you a quick intro to AutoTrader, introduce in a bit of detail our cloud data platform. I'll talk about how we enabled self-serve of data and specifically go into detail about a tool that we use called Looker, and then walk you through an example use case where we've used Looker to good effect to get data exposed to people in the business who need it. So apologies to those of you who were in Paul's talk before, because a lot of these slides are going to look very familiar. For those of you who weren't, though, just to introduce you, AutoTrader is the UK's largest digital automotive marketplace, and it sits at the heart of the UK's buying and selling process, the UK's vehicle buying and selling process, bringing together the largest and most engaged consumer audience with the largest pool of vehicle sellers. So for most people who've heard of us, and we've got pretty good brand recognition, they know us for these, which is our used car classified adverts. If you go to our website and want to search for a new or used car, then you stick in your postcode, stick in some search criteria, and you'll be presented with a list of results like this. In addition to that, though, we offer a number of services for both our consumers and for the retailers who advertise with us. So for consumers, we give tools like valuations, price indicator flags, dealer reviews, ratings, vehicle check reports, etc., to give confidence that the vehicle that people are interested in is both good value for money and that they're buying from a reputable seller. And for our retailers, we offer a number of tools in addition to just the online classified ads, including tools for managing their forecourts, so making sure that they're buying vehicles at the right price, they're sourcing them from the right places, and they're buying things that will be in demand and sell quickly. So AutoTrader is one of the largest websites in the UK. We've got some pretty big stats in terms of kind of the numbers of visitors we get every month. So 50 million cross-platform visits every month, with over 200 million advert views a month. And operating at the sort of scale that we operate means that there are rampant kind of opportunities for capturing and using data and deriving insight from it. So consumers interacting with AutoTrader every day, millions of cross-platform visits every month, with thousands of interactions being recorded every single second. And the types of data that we're recording are more varied than ever before. So historically, we used to record server-side events from our internal systems, but we now capture things from all manner of different sources: Facebook, Instagram, Twitter, how people are interacting with emails that get sent. We record calls that come through to our dealers, online chat interactions. The list goes on and on and on. So we're increasingly capturing more and more data, and it's equally true to say that we increasingly want to make decisions using that data more quickly and often even in real time. And the sort of wider context for this is that the world we live in is becoming ever more data hungry and ever more used to being able to access data as easily as possible. We've got basically live in a world where we've got, with modern mobile phones and internet connections, facts about almost anything at our fingertips. You can wake up in the morning, pick up your phone, search for something without even getting out of bed, which even 10 years before, especially 20 years ago, would have just been impossible. So getting access to data kind of in that easy manner is something that we increasingly take for granted. But actually in companies like AutoTrader and other companies, getting access to data isn't as easy as that. It tends to sit behind internal systems. You've got to have specialist knowledge to get at them. Perhaps there are kind of access control requirements that mean that you can't even get permission to see the data that you might be interested in. And even if you do, it's not obvious necessarily where you would go to answer what could be a relatively simple question, like how many new cars did my customers advertise yesterday? Unless you're a data analyst working in that space, you may not may not be able to get at that data. And the other context is the kind of industry we work in is becoming ever more data driven. Our customers want to know how many people are viewing their ads, which ads are performing better than others, to help them target kind of future purchases so that they're buying things that they know will sell quickly. They want to make sure that they're using data to price their cars effectively. And our consumers as well want to see adverts when they're searching that are most relevant to them. They want to know, is this vehicle good value? And we can help them with that using data-driven products. And the public at large as well want insights into the industry, which AutoTrader, with the wealth of data that we record and process, can help provide. And so it's this in mind that AutoTrader have been building out a cloud-based data platform. And the kind of history behind that, I suppose, is to think about how we used to deal with data. And this is what I've termed the legacy data warehouse. So the way that this works is we've got a bunch of operational databases here on the left that could be anything from our stock management system through to our customer billing processes, etc., that contain data that's of interest. Using a tool called an ETL tool, which stands for extract, transform, and load, what our data warehousing system used to do would be to read data from this on some sort of schedule, like daily, snapshot it, cleanse it, and store it in the data warehouse. So what I specifically mean by that is the cleansing means that these raw tables here in these databases tend to have a lot of information in them, but the stuff that you need to store to do historic reporting is probably at a much lower granularity than that. So to give a specific example, we might have a system here that, we might have a system here that stores every update to every advert that's ever made. Whereas for historic reporting, it might be the case that actually we only need an aggregated view of that snapshotted daily. And that's what the data warehouse gives us. It sort of stores this data historically, and on top of that sits the kind of analytics and reporting layer. So anyone who wants to kind of ask questions about that data would use reports that hit the data warehouse to find that information. And we've achieved a lot with that setup. It's been in place for a number of years now, but it has a number of drawbacks, specifically because it runs on-premise. So it's running in our data centers using our own hardware that we have to buy and kind of plan for. Storing large amounts of data, especially kind of unpredictable volumes, becomes very expensive. Another issue is around the way that we do the cleansing. Basically, it means that you have to upfront decide what data you're going to keep and what data you're going to throw away, partly because storing everything is too expensive. But the problem then comes if you want to then kind of ask a question that's never been asked before, but ask it historically. If you weren't storing the data, you can only do so from this point onwards. And finally, kind of building out this data warehouse requires a lot of expert availability. You need specific data warehouse developers and kind of knowledgeable analysts who can then interpret that data. So it's with that context in mind that a couple of years ago now, the data engineering squad set out on a mission to build out a cloud-based data platform. And we came up with this mission statement. We wanted to empower AutoTrader and its customers to make informed, data-driven decisions, and at the same time, democratize access to data and promote a self-serve data platform. So we started thinking about the sort of personas we thought would want access to this data. And we came up with a bunch of different personas, everything from analysts and data scientists, kind of dedicated data professionals who either want to ask questions about data to derive business insight, or maybe dig into the low-level data to do kind of complex machine learning and tease out insights that perhaps would be beyond a basic kind of SQL query. We've got people like product leads, people developing products who want to know how that product is performing. You go to a lot of effort to build something. You then want to see how it's being used by our consumers, perhaps with A/B testing, for example. We've got our sales teams who want to kind of have conversations with our customers, talk to them about, you know, the adverts that they're putting on our site, what's working for them, what's not, and a whole bunch of other personas beyond that as well. And the crucial thing here is that the requirements for the data, so the sorts of data that these people want to access, are wildly different. They vary hugely. The skill set these people have around data varies hugely. Some people will want to write SQL to access data. Some will want to dig in using languages like Scala or Python, using machine learning libraries. Some will want a drag and drop UI, and some will want pre-built dashboards that give them the answer to the question that they need, and nothing kind of superfluous to that. But the commonality here is that they all want to self-serve. They don't want to have to go to someone else and say, I've got this data request, can you sort it for me? They want to be empowered to go to whatever system and find the answer to the questions they have using our data themselves. And the other thing we were thinking about with this data platform, and especially the kind of new bits of software and technology that are increasingly becoming available, is we wanted to lower the bar in terms of this kind of cost to entry. So specifically making it easier than ever before to get access, while also raising the ceiling in terms of the capability that we provide. So making it easier than ever for people to get access, but also being able to do more than ever before with the data that we have. So the platform that we've built looks something like this at a very high level. There are a few kind of core things to point out here. Oops. At the heart of it, we've got a kind of storage layer. And for that, we're using a multi-cloud setup using on AWS Amazon S3, which is kind of, at its core, just file storage. It allows us to store unstructured data at very large volumes, and we pay only for the amount of data that we store. Sitting alongside that, we've got Google BigQuery, which is a serverless data warehouse that stores data in a slightly more structured format and allows us to query it using tools like a SQL interface. To get data into that, we're using a number of setups, including the approach that we have sort of been using more recently, which is using Kafka Connect. So Kafka is a streaming platform. We use Kafka Connect to read data from operational data stores, put it onto Kafka, and then sync it into the platform, either in S3 or BigQuery. Prior to that, we were using a tool called Scoop, which allowed us to do database snapshots at sort of fixed periods, again, connecting to operational data systems, running queries to select data out, and then sync it into the platform. Orchestrating all of that is a tool that we've been using called Apache Airflow, which is an open source orchestration tool. It's basically a very advanced scheduler. It allows us to write things called DAGs, or directed acyclic graphs, to kind of map out the things that we want to run and their dependencies and on what frequency we want to run them. So that's how we get data into the platform. We then have to process it, and for that we're using a number of tools, including Apache Spark, sitting on top of Databricks and Amazon's Elastic MapReduce, and Paul alluded to in his previous talk, DBT, or Data Build Tool, which is like a templated SQL language for running queries in BigQuery. And then finally, sitting on top is our analytics layer, and for that we're using two main tools. One is Databricks, which I'll talk about in a little bit, and the other is Looker. Again, I'll go into a little bit more detail on next. The kind of common theme with the way that we're processing data, though, is that we kind of go through these data pipelines, ingesting data in its rawest format. I think there are some things that pop up here. Yep. So ingesting data in its raw format and then putting it through degrees of refinement to the point that it then becomes usable and you can hook reports into it. So I talked about this cloud-based data platform, and there are a number of kind of key things that being in the cloud gives us that makes all this viable and possible, especially around scalability and elasticity. So with data, and especially recording data at the sort of volumes that we do, being able to process it is really important. And in order to process large amounts of data, you've got to be able to scale your computation or analysis tool to be able to do that. So working in the cloud, be it AWS or Google Cloud, means that we can fire up compute resource to process data and then terminate it when we're done. And it's that elasticity that's great, because we don't have to kind of plan in advance what we're going to do. We can just request resource to process data when we need it, and then there's no kind of fixed commitment period for it. Being in the cloud also brings great kind of cross-functional requirements around things like security, so we can be confident that our data is secure. So I mentioned the data lake, and for that we're using Amazon S3, which is file-based storage. We're also currently in Amazon running Spark jobs using Elastic MapReduce, which is a sort of managed Spark service that Amazon provides. On the BigQuery side, we tend to, on the data side, mostly use Google BigQuery, and that's great. It's a serverless data warehouse which scales to our storage and computational needs. Basically, that means that we don't have to kind of plan for growth. We can just put data into it as and when we require it, and query vast volumes of data without having to kind of plan ahead. The cost model for that is basically we pay for the amount of data we store over time, and also pay for queries, so pay on read based on the volume of data that's being queried. On the analytics side, I mentioned Databricks. This is a great tool that we use for kind of writing notebooks using languages like Scala, Python, R, and there is a SQL interface as well. It's great for exploratory analysis, so kind of trying out ideas, seeing what works, what doesn't. It's got integration with a lot of advanced machine learning frameworks, and it tends to be the kind of first port of call for our more advanced users, particularly data scientists. You can schedule regular tasks with it and even create dashboards, but the nature of it means that it tends to be our more technical users who use Databricks. For most people at AutoTrader who kind of access our data, the tool that they use is Looker, which is our business intelligence tool, and that gives us a kind of entry point to our data using things like dashboards. You can build models which act as a single source of truth for our data, which is great. It can hook into a number of different data stores, though for us we tend to hook it straight into BigQuery, and it's pretty fast and flexible and straightforward to get started with. So we started using Looker at AutoTrader just over 2 years ago, and since then we are now in a situation where we have over 300 active users every single week using it and querying data, 168 content creators, so people building dashboards, and several thousand dashboards and what it calls looks, which are effectively sort of like single tile dashboards. So it's fair to say that adoption with Looker, given that we're a company of, I think, under 900 employees, to have that many people accessing and querying data in a single week is a really impressive number. And we achieved that by kind of rolling it out in a POC that effectively meant that we were trying to answer a very specific question. So for the POC rollout, we sort of centered that around a new project that was launching at the time called Vehicle Check, which effectively gives a sort of marker on an advert to say that this vehicle has gone through a number of checks and it's sort of, it's not been written off, it doesn't have outstanding finance, etc. And the idea was that we wanted to monitor performance of adverts with and without that flag to prove that it was adding value and that consumers were engaging with it. So we wanted to build a dashboard to help with that rollout. And to do so, we kind of had to define a number of roles. So Looker specifically kind of gives 3 levels of access to data. It's termed viewer, explorer, and developer. So viewer is kind of the most basic level of access, and that just gives access to pre-built dashboards. So it's got a shared folder structure in which we set dashboards and this concept called looks. And the idea is that someone else will build a dashboard, can then share it with the wider company, and then anyone in the company or anyone with the requisite permissions can go in and see those dashboards. The next level of access is called an explorer. And what that lets you do is effectively kind of drill into the raw data and build custom queries, but using a graphical interface and using a kind of pre-built data model that our analysts have defined. So that lets you answer kind of business questions that perhaps haven't been asked before, and explore data in new ways that kind of might be specific to your custom use case. It requires a bit of upfront knowledge around how the data works, what you might be looking for and where to go, but you don't need to know SQL, you don't need to know kind of anything technical to start getting insight from that data. The final level of access is what Looker calls it the developer role. Internally, we tend to call it the data modeling role because it's sort of not the same thing as there's a job title as AutoTrader called developer. You don't have to be a developer to model data in Looker, and equally, if you are a developer, you don't necessarily need the data modeling role. And this is what kind of the role that helps build up that underlying data model. So underneath the hood, Looker has this concept called a view file, which effectively, this is a toy example from their documentation. We don't actually sell aircraft, but the idea is that you define the dimensions and measures in your underlying data and the various types and kind of the underlying SQL query that would get you access to that. Then on top of that, you build in what's called a model, a series of explores, and the explores basically just define how those various view files should be joined together. So a very simple example might be that we have a view file for our customers and a view file for their stock, and then we have an explore that joins those two together. So for each customer, you can see the stock that they have advertised. So we rolled Looker out with the POC centered around the vehicle check use case, and that was a good success. We defined the roles. We got the data that Looker needed into BigQuery, so Looker could sit on top of it. The developers or data modelers wrote some what we call core models, so to represent kind of the core business entities that we were interested in, things like adverts, customers, etc., and built a dashboard to help support the rollout of that product. So that was a good success. Over time, though, we've kind of come up against a number of challenges with Looker. Firstly, in some way, we've become a bit of a victim of our own success. We've seen a bit of unmanaged model, explore, and dashboard proliferation. I showed the stat earlier, we've got several thousand dashboards in place now, which is probably far more than we realistically need. A number of those will be in people's kind of personal folders, just perhaps they're running experiments, just kind of trying out how to build dashboards and things, so they serve no useful purpose, but there are probably a number of dashboards out there all doing very similar things that could probably be consolidated. We also found that people were writing models or extending models for their own very specific use case. Some of those use cases were perhaps useful for other people, and perhaps some of them were a little bit niche. So keeping track of that and kind of modeling that in a scalable way has been a challenge. What was quite interesting is that in the rollout of this, we had identified a bunch of new personas for the data platform that we hadn't initially considered. Things like people in our sales squads who wanted to view and then, what surprisingly to us, explore the data in more detail. People like product researchers, people in marketing, the list goes on. But the more people who have access to Looker, kind of, the more it becomes known in the business, and then it sort of self-proliferates. So that's in some ways a good news story, but it means that there are more kind of roles for us to have to consider. Sounds obvious, but it relies on having well-modeled data under the hood in BigQuery. And there's always a challenge there between people who have some urgent use case, who need the data available as soon as possible, versus kind of taking a step back and thinking carefully about how it's modeled and how it's exposed. And that's been a bit of a learning curve for us. We found that between LookML developers or data modelers, there's a bit of a disjoint knowledge base. So people who work in some squads are sort of siloed and maybe aren't kind of familiar with how other bits of the business work. Whereas we have one shared code base it's backed by Git for our LookML. So keeping track of that and keeping it cohesive has been a bit of a challenge. Equally, lack of ownership. There are some things that are of interest to almost everyone in the company, but there's no clear owner. So it's been a bit of a challenge to kind of make sure that the views and explores that expose those concepts are maintained. And then finally, performance and cost. One of the beauties of the cloud is that resource is scalable, and that if you I don't know, want to run a query against several terabytes of data, you can very easily do so. The downside is it comes at a cost, especially when you're paying per query. So Google BigQuery specifically, the cost model means that you end up paying it's around $5 for each terabyte of data scanned, which when you're rolling out to hundreds of users with a badly modeled dashboard that scans more data than perhaps it needs to, it can lead to some unexpected surprising costs. So we've put a lot of effort into keeping visibility of that and making sure that we get no surprises there. Another thing that's been crucial to success is training. So making sure that people know how to use Looker most effectively, be that dashboard users, explorers, data modelers, etc. And that sits as part of what we've termed the Data Academy, which is not just for Looker. It's a kind of one-stop shop for people to learn about all manner of things relating to data, be that kind of fundamental concepts around statistics and perhaps more advanced topics as well. The various tools that we use, including Airflow and Spark, and some kind of, I guess it's all very well knowing those tools, but if you don't know where to go, how to request access, if you don't have permission, etc., then making sure that that's well documented as well. And the idea behind the Data Academy came from Airbnb and a bunch of blog posts that they've put out talking about how they use data. And there's a great quote that they've given out there, which is to say, in order to inform every decision with data, it wouldn't be possible to have a data scientist in every room. Instead, we need to scale our skill set. So effectively get the whole company trained in how to work with data. So with Looker specifically, we've got 3 streams of training centered around the 3 roles. So for our dashboard viewers, we've got onboarding for specific dashboards. So when people are using dashboard to support, for example, a particular conversation with a customer, there's some onboarding process that goes there. And we've also within the company got a Looker champion network. So a number of people who are considered kind of experts in how to use Looker or a specific dashboard. So if you've got a question, you can go to them. For our explorers, we've got a tailored Looker for business users course, which takes people through the basic concepts of how to use Looker and the explore functionality, and some kind of deeper dives into a few of the example data sets that we have available. And then for our developers and data modelers, we initially thought we'd get away with just peer training, so people learning by pairing up with someone who's already familiar, along with some online resources. But demand has been such that we've now got dedicated training courses centered around that as well. One thing that was interesting with that is because we're using Git and GitHub to manage pull requests, most of our developers are familiar with GitHub, and we just take it for granted that people know how to do that. But the data modelers tend to encompass people who aren't necessarily developers and actually need a bit of training on how to work with Git and how to raise and approve GitHub pull requests. So conscious of time, I was going to just show finally an example use case. So just to put all of this into a bit more context. Using Looker, we rolled out a use case called Performance Dashboard. The idea behind this was to help our retailers understand how their adverts were performing, and it was to be used by our retailer development and support squads to help have conversations with customers. So to help them talk to their customers about how their adverts are performing. Our customers spend money with us to advertise their cars. They want to have confidence that those adverts are being seen by people are interacting with them, and that they're getting good value for money. And the idea behind this was to replace an existing application that was a sort of bespoke application that had been written years and years ago. It had a deprecated backend. The front end had become unmaintainable. we needed to do something with it to bring it up to date. And we thought, actually, we could do this rather than write a new application from scratch. We'd be able to do this just using Looker. So we built what were actually a series of relatively straightforward, simple dashboards with links between the different metrics of interest to show things like how there's at the top here, there's a set of customizable filters. You can give each of our retailers has a unique identifier, so you can just enter that there. Change the date range, anything from the last week up to the last 18 months. Group it by either day, month, or even year, and then show trended metrics over time for things relating to search appearances, advert views, leads, etc. And this was great. It was a good success in that it allowed us to replace a legacy bespoke application with just a couple of dashboards in Looker. What was really good is that the dashboards were built by our data analysts. We didn't need any developer input. So if we'd done this ourselves to build a new application, we'd have had to get a front-end dev or a couple of front-end devs, a couple of back-end devs, a whole dev team to support the development of it. Whereas we were able to just build it on top of the platform using the existing tools available. And those dashboards are now in day-to-day use with our retailer development and support teams. And that is everything I was going to talk about today. So thank you very much for your time.